Today in this video of lesson 8.4 vectors in three-dimensional space, we will study how to perform the operations on the vectors in the space. We will see how can we add the two vectors. Remember that if the two vectors are given, so for example, we have the vector 1 with the components x1, y1 and z1, and another vector which has the component named as x2, y2 and z2, and you have to add them. So in order to add them, remember the x component of the first vector will be added with the x component of the second vector. So you will get x1 plus x2. Similarly, the y component of the first vector will be added with the y component of the second vector, which means that the y1 plus y2. And in the same way, if the z vector is given, named it as z1 for the vector 1 and the z2 for the vector 2, then they will be added. So in short, the z vector will be added with the z vector, y component will be added with the y component, and x component will be added with the x component. Now, rather than positive, if they ask us to perform another operation, that means you subtract it. Rather than addition, we have to subtract it now. So in order to subtract it, what do we do? We subtract y1 minus y2. Okay, whatever the vector is written first, you have to write it first. So if x1 is written first, so you write x1, and this is the subtraction sign, so minus and then the x2. Similarly, y component y1 minus y2, and in the last z1 minus z2. So this is how we perform the addition or subtraction of the vectors. Now the second thing is scalar multiplication. So let's suppose a vector is given named as with the components x, y and z, and you have to multiply with any constant vector, any scalar quantity, that is k. It could be 2, 3, minus 4, minus 5, anything. So what you have to do, this scalar quantity will be multiplied with each component of the vectors. So k times x will gives us kx, k times y will gives us ky, and k times z gives us kc. So this is how we have to perform the addition or subtraction of the two vectors. So here we are asked to find 3v minus w minus z. So let's see here. So 3, and the first thing is written as 3, and what is written? V. So V is, so it is 3V, right? So 3V is 1, 5 and 2. The components of the vector V are 1, 5 and 2. Then it is written minus W. So you write here minus and W, which means that you have to multiply or multiply the whole vector W with the negative sign. Okay. Now the last thing is minus z. So right here minus z. It means you have to subtract or multiply the whole vector of the z with minus. So minus and z is 0, 5 and negative. Look what I am trying to do. I am trying to just simplify my question. So multiply the whole vector of the components of the v with the 3, which is the scalar quantity. So 3 times 1 is 3. 3 times 5 is 15, and 3 times 2 is 6. Now, if you multiply the whole vector of the w with the negative sign, what you will get? You will get negative, negative, positive 6. Negative times 3 gives us negative 3. Negative times negative 2 gives us positive 2. And now the z components, multiply all the components of the z with the negative sign. So negative 0 will gives us 0. Negative times 5 will gives us negative 5, and negative times negative 1 gives us positive 1. Now in the end, what you have to do, you just add all these vectors and that would be your final answer. So 3, all the x components will be added. 3 plus 6 plus 0. So it will be 9. 15 minus 3, 12, plus minus 5, it will give us 9. So 15 minus 3 is 12, 12 minus 5 gives us 7. Now 6 plus 2 is 8, 8 plus 1 is 9. Now sometimes the students, rather than doing like that, they do it like other way. So let me just show you the other way so you don't get confused. If you like whatever the method you like, you do it. So you write the 3. Okay, V is 1, 5 and 2. Then minus, and W component is negative 6, 3 and negative 2. Minus, and the Z components are 0, 5 and negative 1. So how you can perform is, the first thing is that you multiply the whole vector of the V with the 3. So 3 times 1 is 3, 3 times 5 is 15 and 3 times 2 is 6. Then minus and keep the other vectors as it is. Keep the other vectors as it is. Do not change. Okay, once you are done, because there is no scalar quantity outside the vectors, that's why keep them as it is. Now what do you do in the end? You write all the x, perform operation on the x component. So this is 3 minus minus 6. So 3 minus negative 6 minus 0 minus 0. You can write all the x components all together. So minus minus 6 plus 3 plus 6 will give us 9, which is our same answer as we did before. Now for the y component, we will write here 15. Then here outside minus and then 3. So minus 3. Then outside minus and inside 5. So minus 5. So if you write this, you will get 7. Now the last thing is 6 minus and then minus 2. And then this minus outside minus, and this is minus 1. And then you write this in the calculator and you will get the 9. So which means that either you go this way or that way, both gives us the same answer, but I like this way because this is simpler and the chances of doing mistakes is less in this case. So next question, 3u minus 5v. So let's see here, 3. And what is our u components? Are negative 3, 3 and negative 2. Then minus 5, and the v is negative 1, 4 and 3. Okay, simplify them. So 3 times negative 3 is negative 9, 3 times 3 is 9 and 3 times negative 2 is negative 6. Now what about the next vector? Negative 5 times negative 1, it's positive 5. Negative 5 times 4, it gives us negative 20. And then negative 5 times 3 gives us negative 15. Now add them to get the final answer. Negative 9 plus 5 gives us 4. 9 minus 20 gives us minus 11. Negative 6, negative 15 gives us negative 21. So our answer is 4, negative 11 and negative 21. So it should be negative 4 because negative 9 positive 5 gives us negative 4. Next question, the same way. First of all, write the 3. And what are the x components? Are 3i, 2j minus k. So in the vector form, we can write it as 3, 2 and negative 5 because this is the linear combination form. So we will write here 3, 2 and negative 5. Now plus 2y. So now write here 2. And what are the y components? Before the I, there is no coefficient, means 1. So 1, negative 5 and z component is 7. Then we have minus 4z, so minus 4 and z components are negative 2, positive 12 and 4. Now multiply them. 3 times 3 is 9, 3 times 2 is 6 and 3 times negative 5 is negative 15. Similarly, 2 times 1 is 2, 2 times negative 5 is negative 10 and 2 times 7 is 14. And the last is negative 4 times negative 2, 8. Negative 4 times 12 it's 48 with negative sign, and then negative 4 times 4 gives us negative 60. Okay, now add them all together because adding is easier than the subtracting. 9 plus 2, 11, 11 plus 8, 19. Then 6 minus 10 is negative 4, negative 4, negative 48, it's negative 52. Negative 15 plus 14, negative 1, negative 1, negative 16 gives us negative 17. Next question, find minus 6y plus 2z. So first thing we will find negative 6 and y. What are the components of the y vector? It's written in the linear combination. You write it in the vector form, that is component form. So it is 1 because the coefficient of I is 1. Then negative 5 and 7. So write here negative 1, negative 5 and 7. Then we have plus 2z. So 2 and then z. Z components are negative 2, 12 and 4. Remember, I represents the x component, j represents the y component, and k represents the z component. So minus 2, 12 and 4. Okay, open the brackets. Negative 6 times negative 1 is 6. Negative 6 times 5 is 30. And negative 6 times 7, negative 42. Here, negative 2 times negative 2 is 4. 2 times 12 is 24. And 2 times 4 is 8. Now, what we have the next step? Just add them. So, adding is easier than the subtracting. Okay, 6 plus 4 is 10. 30 plus 24 is 54. Negative 42 plus 8 gives us negative 34. So negative 34. Yes. So this is our answer. Let's try one more question. Minus v, which means multiply the vector of v with negative sign. So 1, 5 and 2. Then plus 2w. 2w means 2 and then w components are negative 6, 3 and negative 2. And the z is plus 3z. So 3 and z multiply 3 with the z vectors, which is 0, 5 and negative 1. Okay, multiply negative 1, negative times 1, it's negative 1, negative times 5, negative 5, negative times 2 is negative 2. 2 times negative 6, negative 12, 2 times 3, 6, and 2 times negative 2 is negative 4. 3 times 0 for the z vectors. So 3 times 0 is 0. 3 times 5 is 15. And 3 times negative 1 is negative 3. The last step is that we will add all the vectors. Okay, so our final answer, negative 1, negative 12, negative 13 means add all the x components. Okay. So negative 13 plus 0 gives us negative 13. Negative 5 plus 6, 1. 1 plus 15 is 16. Minus 2 minus 4 minus 6 minus 6 minus 3 gives us minus 9. So this is our final answer.